So we have been so there have been we're coming to the end part of this thing. So there have been there is a continuous theme of the limitations of measurability, and what it has to say something about the predictivity as humans, and how it has we have to revisit our deterministic philosophy in the sense that, for example, uh, so there is no limit. There are no limitations of measurements of past values. Only present values cannot be measured exactly. And it's bound by Heisenberg's uncertainty about simultaneous indeterminacy of measuring two conjugate variables. And this limitations puts constraints on the sufficient limits of predictability of future states. So knowledge of about past values cannot say it's not how we can predict future values. It's not sufficient determinant to just find future states. So we can have whether two-valued interpretation of logic. We can just rehabilitate these statements accordingly in a very but what I should say. So when we say measurement prior or measurement, what was the measurement? What we have measured, our measured value specifies the value of that eigenvalue. So to what was prior to it is meaningless in the Bohr-Heisenberg interpretation. But in the three-valued interpretation, we can just say this meaningless as a quantity can be just replaced by the word indeterminate. So we can have its own how we can relate it in that sense. So in the history of debates of philosophy of quantum mechanics, maybe there is one debate of Einstein and Bohr, and it has been properly documented in that famous paper, Epistemological Problems of Einstein with Bohr. And another paper of this quantum mechanical discovery or description of the reality we considered complete. So there are words like reality. So Einstein had or the people Rosen they had a prayer that a human that belief that there is a pre-established causal order, harmony of causal order, and the interpretations of Bohr-Heisenberg interpretations of how we construe measurement value of the quantum reality is after measurement. So what the quantity was in that sense, it's besides the point. So in order to rescue that idea of reality, which should be objective, which should be exist, and it should be untinctured, and there is a certain causal innate order work. So to brush away or to just have an interpretation of quantum mechanics, which is different from Bohr Heisenberg interpretation, or rather controversy in that sense, if you want to use harsher word. So that is so in a thought experiment, they try to interpret it. So we are trying to see Reichenbach's understanding of this Bohr-Einstein debate or controversy or disagreement, whatever you want to see it, via his way of understanding in terms of three-valued logic. So before we are going to say it, so there is a comment by him, Reichenbach, I'll see, that this issue, this controversy, if I use his words, again he says it can be addressed without any metaphysical assumptions. These things can be stated without any metaphysics. When we use concepts so it is easy to give an answer when question reads. So here again, the idea of trying to negate metaphysics. So maybe the metaphysics, maybe this Reichenbach says, maybe repellent of maybe sort of theology, a certain set of theology which necessitates certain metaphysics. It might be a repellent as a part of beginning of 19th century or late 19th century or the beginning of 20th century. So we can see it. So it's basically that in that sense. Even Einsteinian causal order can be placed in a metaphysics, Pythagorean or metaphysics, mathematical, philosophical metaphysics of that eternal order, causal order. But I think in the spirit of age, the interpretation of quantum mechanics or interdeterminacy, which is attached or associated with it, it somehow opened a can of uncomfortable interpretations. So the spirit of age had been laid, enlightened age against theology, against metaphysics was seen only through theology. So a sort of divine order, which could be just you could also interpret it as some if our incapacity is there, it's part of some divine order or design. And in that context, I think these metaphysical, he wants to just do away with these metaphysical assumptions. But to me, metaphysics is a broader term. It's being, qua-being. It's not only, it's the existence behind the existence. And it may not necessarily be empirical or materialistic in that sense. So that this is a brief comment. So before we are so now we are going to what we are going to say about Einstein, Podolsky, and Rosen experiment. How they try to just do away with this thing. That the famous thing of what I should say. So this EPR. So normally they to rescue the idea of objective reality which should be there, the value of a given entity or measurement prior or after observation, it was there, it was something. And it's not that your measurement will give meaning or reality to what you are observing. Observer gives reality to observed. It might have its own. So in order to rescue this thing, they work through a contrived idea via correlated systems to, for example, rescue this idea. In the sense that there can be two systems which are correlated uh, such that measurement of an entity in one system determines the value of an entity V in other systems. Although, so measurement of an entity in one system determines the value of entity in the other system. Although later system is not physically influenced by the act of measurement. The authors believe so. You can so you to just this have to dispute this idea of reality, which is not a quantum reality where measurables are dependent upon the what operator value measurement, but existing prior or after to it. So they imagined a correlated system where measurement of an entity in one system determines. So you can think of it in that sense. How we can think of it in that sense. So there is a more which there is a plausible proof which is given in their paper. If we consider if you refuse to consider that a measured value as holding long before measurement, as Bohr Heisenberg interpretation does. So in order to analyze this thought experiment, we are going to see how we are going to just articulate it in that sense. So what we are going to do is so what we are going to do is, for example, if we assume two particles which for some time enter into reaction, for example, psi function, psi function be a function of psi q1, q2, so on q6, six coordinates. So after interactions, particle separates, the psi function will be given by psi product of individual particles. Psi of q1, q6 will be sigma I, sigma k. So this is some this arbitrary thing, matrix or operator, which is having on this function q1, q2, q3, and another phi I, phi k is q4, q5, q6. So sigma ik is, for example, so after interaction, if it's given by this phi 1, phi 2, it will be after interaction q4, q5, q6. So if we expand individual psi functions in the eigenfunctions phi, then q1, q2, q6 can be I, k, sigma, so it's fine. Now if you remember, we had a probability of ui uk is basically it's sigma ik square, or if I is k, then sigma ik square it's 1. Now here this sigma ik square further, if you have given wave function psi, this can be equivalent to this is further equivalent to 1 or 0 if I is equivalent to 1 or I is not equivalent to 1. So since the second system is not involved in the measurement, its part 1 remains unchanged. So therefore the new wave function results from y1 simply from the cancelling the terms possessing with sigma ik. This means I not equivalent to 1. So now new wave function will be q1, q2, q6. It will be sigma k, sigma ik, q1, q2, q3, q4, q5, q6. So it will be phi of q1, q2, q3, sigma of k, sigma 1 k, phi k. Q5, Q4, Q5, Q6. So again, so you can have initially you can have this one, this goes to this. If this remains same, so you can have for this you can have this thing. Now the new wave function is this q1, q2, q3. Sigma of now you just have this. It's changing by some this transformation. So again you can have we can have we can have what I should say, sigma ik square is equal to sigma k du k ui uk, or d of ui1 is equal to 1. So now what we are going to put, just like we put our operators. So we put a function tau of 1 to chi2 q1, q4, q5, q6 goes to sigma k, phi of ik, sigma ik. So this is some operator. So first we had psi goes to this. Now this change to this. Now this will again change to some thing. We can relate tau with sigma via operator this q4, q5, q6. So this assumes that psi q1, q2, so and q6 goes to tau of 1 to q1, q2, q3 and chi2 of q4, q5, q6. So the introduction of new wave function psi is called reduction of wave function, reduction of wave packet, sorry. So now this can be shown, the measurement can be shown as q4, q5, q6 represents the eigen function of the entity v, and this is u. Yes. This means if we will do numbering to this equation, this means 8, this is 7, this is 6, this is 5. So this means that it will result in the measurement of both this one as well as this one. Measurement of u and v both. So measurement of u and v both. Although only the measurement of u has been made. Although only the measurement of u has been made. Yes, yes. Although we have measured only u, we have only measured u. We have only measured u. Yes, 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 yes. So, but you can, you can. So from this you can also construct. It can be proved that if there is a u in first system and psi function resulting in the quotients of sigma ik of 1 vanished as all at all values except sigma 1 2. So what do you mean by that? Psi of q1 q2 q6 is sigma 1 2 phi of 1 q1 q2 q3 q4 q5 q6 and sigma 1 2 square is equivalent to which means that measurement of the first system resulting in u1 has made second system definite. Has made second system definite, and that's fine. For value of u2, for value of u2, yes. So for a correlated system, the measurement of one system has made measurement of the second system, the correlated system, priorly definite in that, because it's somewhat related. So you can, for example, we can have an conclusion of this APR is that value of u2 exists in the second system prior to measurement of u is made in this system. So if you don't agree to this thing, so otherwise we are led to the consequence that measurement of u in the first system produces not only the value of u1 in the first system, but value of u2 in the second system. In the first system, but value of u2 in the second system. So this means we can say that this represents an NL. So this represents an anomaly because measurements in the first physical system doesn't affect the measurements in the second system. So this is a sort of main argument. So without going into the context of details, so we have therefore a free choice. So what's the context? We have a free choice to measure u in first system and thus to make second system definite in W. So this is so we have a choice to measure u in the first system and thus make second system definite. So this suggests that entity value of entity exists prior to measurement, which is in a sense. So in this reply of this construction, what Bohr set forth is that he thought of a thought experiment, which is famously there. You can go. So you can have either its measurement of each particle, for example, for the determination of momentum of. So if we constructed that experiment in which what I should say, two particles are there. What I should say, two particles each passing through a slit in the same diaphragm, and if we measure, so we can have a diaphragm and particles passing. Two particles are passing through a the same diagram. So diaphragm. So it's possible to construct measurement of position as well as momentum. So for the momentum measurement of the second momentum, so the way we do elastic collisions, measurement of we can take measurement of particle before the particles hit the diaphragms. We have to know measurement of the diaphragm before the particles got hit. Moment of the diaphragm after particles got hit. Moment of the first particle after the particles. So from this we can determine the moment of the second particle is determined by, by the subtracting the change in the moment of the particle and change in the momentum of the diaphragm. So in order to determine the momentum of the position of the second particle, we would measure the distance between slits and the diaphragm and the position of the first particle immediately after. So from this argumentation, what we can get is that so maybe I'll just you can read it. I'm not able to articulate what the crux of the Bohr's argumentation is that it's that although according to Reichenbach he is using the same sort of vocabulary the way used here for correlated system, but in some way it doesn't change the validity of the Bohrian argument in some fundamental way. So in that sense, what he's trying to say is that difference between the measurement could not be interpreted as equal to amount of. So I'll not. So maybe it needs a separate class to discuss this experiment. So the crux of the experiment is Bohr uses an exhaustive interpretation free from anomalies. So Bohr switches to an interpretation. So how we can do away with the causal anomalies, whether in the restrictive interpretation or whether in that exhaustive interpretation, they both have some limitations. So in a given description, one might switch to the corpuscular interpretation, or whether one might want to choose the exhaustive restrictive interpretation or corpuscular interpretation or wave interpretation to explain things. So it's a sort of a pragmatic thing in that sense, pragmatic methodology of to explain things. So now we are coming to how Reichenbach wants to. He just, although he just in an implicit way is endorsing this Bohr interpretation, Bohr-Heisenberg interpretation, but the argumentation is that from that of a three-valued logic. So what he is using is that the doing away of these causal anomalies. For example, so in the traditional quantum mechanics, which is a two-valued logic, which is two-valued logic, quantum mechanics is associated with it, and whether we go for a restrictive interpretation or exhaustive interpretation, particle interpretation or wave interpretation, so we can have it. But once we go to three-valued interpretation, where the idea of indeterminate is to be had symbolic justification from a neutral interpretation, to use his words in the earlier thing, that accounts for example, a statement it's the value of an entity, before measurement is different from the value resulting in measurement. Then what existence of the correlated system proves that if causal anomalies are to be avoided, the statement A must hold. A must hold means one is A. This is the negation of A must hold. So A negation of A must hold. So this means that or A bar is false. That false is false in that sense. A is not true. Yeah, A is not true, not true. Doesn't mean that A bar is false. So value of an entity before measurement is equal to value entity after resulting in the measurement, which is denoted by this. That is this. So this entire thing can be seen via this three ways. So we can have statements the way we have synthetic statements. We can have a truth statement, and the other statement may be true or false, or other may be true, false, or intermediate. False acting on true statement, true acting on false. So one part of the statement is true. So in the conjunction, it's having a true statement. For a simplest synthetic statement, the other statement may be false or true. But if it is indeterminate, So this may account for the many valued interpretation of quantum mechanics, which is neither exhaustive, neither restrictive, but it can be neutral. And in that, it might account how we can deal with idea of only, only three, according to Raikkonen, three valued logic gives correlation of system holding even before measurement, thus to eliminate three valued logic gives the means to state the correlation of the system as a condition holding even before a measurement is made, thus to avoid causal anomalies. So now in the conclusive part, he's talking of how this idea of how the book has started with this restrictive interpretation, that thought experiment, famous thought experiment, or the understanding of Young's double slit experiments, not for light, but taking this world as quantum mechanical. And something, the idea of quantum, it contains in it the idea of waves and particles enmeshed in a very intricate way. And in the process of trying to interpret that experiment, there are various anomalies which come out, and those anomalies can be either done away, either if we have a particle interpretation or if we have wave interpretation. But the point is that the anomalies can only be eliminated in a whether causal anomalies are related in some in the both the interpretations, how those anomalies can be done away with. And these things can be very well, the language here is a two logic system. But if we have three valued logic, the idea of anomalies being done away with can be seen as basically quantum mechanics, the language of quantum mechanics is wide enough such that the language of quantum logic, the language of three valued quantum systems, which is very wide, it has the possibilities of or potentialities of having descriptions which includes particle, restrictive, exhaustive, as well as neutral interpretation in this three value. So in the idea of how indeterminate is also the way we have a pillar of truth, falsehood, and there is indeterminate, it can be. So here, it's there can be a question. So whether it's our description of language or logic. Is it the description of the physical world is basically, it's not the juggling of language or logic of language. It's basically the prior existence of many realities which have their parallels in the quantum logic, which may be more than two valued. So a bit of what Reichenbach is, his philosophy is that of logical philosophy. So at the end, where would I like to place Reichenbach's study of quantum mechanics. So his study of quantum mechanics can be from the epistemic sense, epistemic foundations. So maybe you can say he was not scientific realistic in the sense that he tried to accommodate the knowledge of quantum mechanics in his empirical part of the thing, and logic, how language and logic together, how they can. So these two. So that's why he was called a logical empiricist in that sense. But in that logical empiricism, he also used the ideas of probability. So empirical probabilist, you can say it that way. That there can be more than one. So in that sense, he somehow deviated from Kant. Kant was a transcendental idealist in that sense. Somehow, in a portion of Kant's entire modicum of philosophy, somehow also rehabilitates it. You can say idealism and materialism and so the portion of this a thing which is not empirical can be seen here. So in that sense, you can say he is hardcore empiricist and logicist, but he's not a logician of the type of Frege Russell in the sense using logic in that binary states. So his logic is somewhat he has constructed his own quantum logic, which is not too valued, and which is he feels is suitable. And in the process of scientific methodology, he is also in the process of that Cohen and Popper. He is also trying to say things can be verified in an inductive way. In that sense, yes. In that sense. So at the end, one important further point which you could say is that one other point which you could say is the last point which I could say is so indirect way. So it's known as probabilistic empiricism. Is interpretation, a particular interpretation of probability, which may not be, which is a frequentist. So here, one last comment which I would want to make is that so one has not to be necessarily so logical empiricism as a construct from which is a dominant construct from which we can what I should say interpret the transition from classical to quantum transition. If earlier causal determinism, materialism, and empiricism could be rehabilitated in that classical physics, but the transition, if it questions some of the things, pillars of that classical thing, so for Reichenbach, he still wants to rehabilitate the new realities within the logical empirical part of things. Even though it may not be, the sensibility may be logical empirical, but even though there may be methodological limitations or fundamental conceptual limitations given by the measurability of things. So does this say, in a sense, I will end at here, does this say metaphysics, which is a remnant, an overriding theme of 19th century or beginning of 20th century starting from. So does it mean that metaphysics, and how we define metaphysics? It's also a question. Metaphysics, one is theology, the other is metaphysics. It's a very thing, the groundedness of being. existence. So, on the idea of essence, or so how that metaphysics, metaphysics, whether it's theological metaphysics or whether it's materialistic metaphysics or whether it's metaphysics a la logical empiricism. So whether our description of quantum mechanics is the metaphysics, even though we don't in textbooks, we conveniently somehow just wish away these things by using words like Copernican versus this and this versus that. And there are studies where we talk of metaphysics of quantum mechanics, but the metaphysics of quantum mechanics is only in that logical empirical thing or deviations from that. So here I'll stop to see this the metaphysical aspects of quantum mechanics. How much have we ignored them? Can we ignore them? Or is metaphysics to be which metaphysics to be seen? The whole notion of science and notion of quantum physics. How can deal metaphysics as a philosophy? Metaphysics, how can have a metaphysical interpretation of things in general, and what is metaphysics in that sense, and what is the quantum mechanical understanding of things, which may not be entirely logical, empirical. The metaphysics part of it, which Reichenbach and whole school wants to somehow do away with it. So it's to my understanding, it's a good question. Start here.